Right, so this is the final investment appraisal method, internal rate of return. It's rather complicated and it's not as intuitive, so please make sure that you watch through the lecture, check how to calculate it. There are two methods. Generally, according to the definition, it's a rate of return which makes net present value equal to zero. It's not particularly clear definition, and strictly speaking, mathematically, from the mathematically correct point of view, the approach would be to use this formula. So we would just lay out our cash flows as we do for the net present value and then equalize them to zero and then solve to find this R. So for example, here in the lecture, I provide an example. We are analyzing an investment opportunity. We want to buy a property which is worth 500,000. We plan to keep it for 3 years and then resell after 3 years at a higher price, 685,000. Or we could generate a 7% return elsewhere. And we ask to calculate the internal rate of return. And in the lecture, I go through this example in details. I explain how we lay out the net present value to decide whether this project is worthwhile. But then, instead of calculating net present value, we make it equal to zero, and we replace this number 7 with the unknown internal rate of return, and solve this equation to find it. What IRR, internal rate of return, would make it equal to zero. However, what the actual meaning is, what does it mean to calculate the internal rate of return? What does it show in reality? It simply shows how much return your project is generating. It's a rate of return from this project. It's how much you are earning while your money are invested in this project. And this explanation is much simpler and easier to understand. The thing is, in reality, in order to calculate it, you don't lay out the formula for net present value. Instead, what you will do, you will apply this formula. Again, it's not particularly intuitive. It's not very easy to understand. So make sure that you watch a lecture. In a lecture, I go into details how you calculate it. In fact, it's a trial and error method. You select one discount rate, which will make your net present value positive, and one high discount rate, which will make it negative, and plug the numbers into the formula. Net present value is always calculated at a certain discount rate, and it can be positive or negative. The thing is, if you use a very high discount rate, net present value will decline. It can actually become negative because you discount all future cash flows by a significant amount, and it might happen that the net present value at a high discount rate can go into negative area. If you use a very low discount rate, the chances are your net present value can be positive. So it varies with the discount rate. And internal rate of return is the value which makes it just equal to zero. It relies on this graph basically. Net present value drops with the discount rate, and internal rate of return is the rate which makes it just equal to zero. So what you do in real life, you try to replicate the shape of this graph. You select some points somewhere on this curve and try to see, if you draw a line between these 2 points, where they would cross the horizontal axis. So you're trying to find some approximation of this. You select 2 values, one low value for the discount rate. Low value would generate a point somewhere at the top part of the graph where net present value is positive. You also select a high value for the discount rate. Just guess. Just, get any number, 20, 15, 10, whatever you feel is appropriate. You need to find a discount rate which would make your net present value negative. Some point somewhere here. Calculate net present values at both high and low discount rate, and then plug all of these numbers into this formula. Don't try to understand why this formula looks like this. It's just a mathematical way of approximating the result. You don't need to understand how it's been derived. The result will be approximate. You will not get the full correct answer, but it will be more or less decent. And here in the lecture, I show an example how you calculate it. Let's do this process with our situation, with our specific example. Here, we are given this number straight away. Have a look. Cost of capital is 5 and net present value is 680. Then, this is the low discount rate, RL, low discount rate. And this is net present value calculated at a low discount rate. Next, when cost of capital raises to 14%, net present value becomes minus 115. It becomes negative. And this is what we need. We need one positive net present value, one negative. So 14% is the high discount rate, while 115 is the net present value calculated at this high discount rate. These are the meanings of these terms in our formula. And all we need to do now is just to plug them into this formula. So low discount rate is 5%, high discount rate is 14%. We've just been given this. There might be some exercises where you are asked to select any discount rate. Just choose whatever you feel is appropriate. If you happen to generate both positive net present values, change one of them, get another one, higher or lower. If you happen to get, again, two negative numbers, change one of the rates and try to recalculate them. It's a trial and error method. You won't get the exact results straight away, but that's how it's done. We've been given these net present values, and all we need to do in this exercise is just to plug them in. And that's all. So low discount rate is 5%, our first term. Net present value at a low discount rate is 680. You divide this by the difference between two net present values. Here, minus will change to plus because our net present value at a high discount rate is negative. So what we have here, 680 divided by 680 minus 115, which is 680 divided by 680 plus 115. And this is what we have here in brackets. And then we multiply by the difference between these two discount rates, 14 minus 5%. That's all. If you do these calculations, you will get this number, 12.7%. Those of you who have managed to understand what to do with the formula got the correct result, right? And here you are just given out the numbers straight away. Your role is just to plug them in. That's all. This is how it works. So if you sketch a graph, this is your net present value, which changes with the discount rate. You don't know how your curve looks like in reality, but you are trying to approximate this. So you found 2 points. One was 5%, one was at 14%. Net present value at 5% is 680,000, and another one is minus 115,000. And what you are doing, you are trying to draw a line and find a point where this line would cross horizontal axis. The result is approximate because it will be a line rather than a curve, but it will be pretty close to the correct value. So this is the correct value of IRR, where the curve crosses horizontal axis. And this is our estimate, our estimate, 12.7%. The actual number is somewhere there, because we don't know what the shape of net present value curve is. Okay? Any questions based on this? So strictly speaking, all you need is just the formula. And I would suggest that you write down all of these formulas on a one piece of paper and put it by your side when you will do your test, so that you don't need to go through all lecture notes, wasting time trying to find relevant formulas. Just make a notes, write the main material in one page and keep it by your side, because it's an open book exam. You can refer to your notes, but it takes time. It's really time consuming if you need to find relevant information in slides all the time. Just write everything down, the most important concepts on one page, keep it by your side with all formulas, download the tables. If you can print them out, it will be quicker for you, and you will be able to answer questions easily in the exam. Next question. The company considering the following project, calculate the internal rate of return. Here we are not given numbers, we need to do it ourselves. This is the same formula which we'll need to use. So the process involves selecting two discount rates, trial and error method. Just select two numbers, 5 and 10%, 5, 15%, 3 and 20%, any numbers. Strictly speaking, the closer they are, the more accurate your result will be. But your result can vary, so two students can do the same exercise, get two different numbers, and both numbers will be correct, because the result will depend on the discount rates you've chosen. And as long as you follow the correct method, the result is approximate anyway. We don't know which one is more accurate. There is no way of determining this, but as long as you follow the correct method, you will get some idea. So for example, here, I've laid out a table where I've chosen 12% and 16%. You could have chosen something else. It could be 5 and 15 and so on. But this is how the process works. These are our cash flows, copied from the original table. So we invest 4,000 initially, and then we generate certain cash flows. These are our cash flows which we have. Then I've copied the discount factors from the present value table. We need present value rather than future value. So here we have 12% column, and we don't have for 15% here, but I've calculated them. So generally use the ready ones. If you want to save time, maybe use the numbers from the from this table. So don't select something like 13% or 17%, which are not pre-calculated. Use the ready numbers. we've got the discount factors from the table or pre-calculated. Then we apply this discount factor to relevant cash flows. For example, cash flow of 4,000 times the discount factor is 4,000 with the negative sign, because the first original outlay happening in period 0 is not discounted. Next, cash flow 1,200, applied relevant discount factor, its present value is going to be 1,072. Next, cash flow 1,410 multiplied by discount factor, got this, and so on. So we've done this with every cash flow and calculated the present value. This is our net present value calculated at discount factor equal to 12%, which is our low discount rate, RL. It's a lower rate, right? Now we need to do the same. This is the low rate at RL, low rate. And this is discount factors at RH, high discount rate. Now we need to do the same with the high discount rate. So if our discount rate is 16%, for example, this will be a set of our factors, and we do the same thing. We take our cash flows, multiply them by our discount factors, and we will get these values now, different set of values. So these are present values, net present value at a low discount rate, RH, which is 16%, high discount rate, right? At RH. Two different present values, net present values. And we're lucky here that one is positive, one is negative, and they're pretty close to each other, right? If you've chosen 5 and 20, they would be more distant apart. One would be very high, one would be very low, so your result will be less accurate, but it doesn't really matter, to be honest, as long as you follow the correct procedure. And now, as before, plug everything into the formula. RL, low discount rate, 12%, RH, high discount rate, 16%. These are our net present values, which we've calculated. That one, plug everything into the formula, and you will get approximately 15%. If you've used other numbers, you might get 16% or 14% or something like that. In any case, it's approximation, and we cannot say that your number is any less accurate than mine, as long as you follow the correct procedure. Okay? This is the approach. This is how you do it. Here in the seminar workbook, there are also a few complex exercises which give you details of a project and asks you to calculate all sorts of metrics: payback, accounting rate of return, net present value, compare them, advice, etc. Try to do something like this as well. They're available in your seminar workbooks. Try to do this practice. All of these questions will be included in your final assessment. And apart from this, in the seminar workbook, there are some multiple choice questions. So please make sure that you work through this. I've deliberately included more exercises than we could potentially cover in a seminar, but it's just for your additional practice, to ensure that you practice and master these techniques, right? To be honest, I spent quite a lot of time detailing all of these explanations. They're all on Moodle, so every single exercise has detailed explanations with comments and everything. Have a look, but try to practice. This exam probably will be the hardest, but I do hope that you scored good marks on economics, to be honest, because this was easier. But believe me, your accountancy modules in the future are going to be even harder. Yes, this is just an introduction. It's just an introduction. It's going to be, some topics are rather complex. I have to say, I have a CIMA qualification. I'm a qualified CIMA accountant. So I've been through this, and I studied for CIMA qualification. I didn't just get exemptions. I've got a few exemptions, but I studied and I passed CIMA qualification. And believe me, some topics are hard. Yes, they're hard. They're difficult. But you'll get there. Don't worry. It will all come in time. Yes. If you're not struggling at university, this means that you've chosen the wrong university. It means that you are not challenged enough. You need to train your brain. It needs to be challenged. When you go to the gym, if you want to grow the body mass, if you want to improve your body, you need to challenge yourself. The same with the brain. Your brain will develop only if you challenge it. Okay? So best of luck. Please try to complete these exercises, do them at home, and I'll see you again next week.